Hey, what's up, everybody? It's Miss Brothers. Hey, you know what? It's going to be fun to balance chemical equations. That's right, you guys. So last week we basically worked on taking word chemical equations and we turned them into skeleton equations. And now what we have to do is we have to take our skeleton equations and make sure that they adhere to the law of conservation of mass, which basically says, in a nutshell, whatever I have on one side of the equation, I need to make sure I still have those things, even though they might look a little different on the other side of the equation. And this is the process that I gave you in class on Monday the 6th. And these are the steps. We set up each side with our correct elements and quantities. We check for balance. We add any necessary coefficients. We update our quantities. And by quantities, I mean the atoms of whatever we changed. We check for balance, and we do this until our equation is balanced. It's not as hard as you think, but sometimes it can get a little bit convoluted. So this process is one of those things that I really stick to because, as a young chemistry student, I struggled with balancing equations. This was my lifeline. This process right here was my lifeline. Okay, so I'm going to keep that close by to just kind of remind us. And I'm just going to go through these problems. Some of them we've done already, but for anybody that might have missed class today, I'm going to go through this first practice and do them all. So step one says I have to set up each side of the equation. And by each side, you guys, I mean each side. So left side of the arrow, right side of the arrow. And I do that by simply going through and looking at what I have. So I have potassium, I have bromine, and I have chlorine. And I put the little equal sign there because I have to also put how much I have of each one. Now, I'm going to put the same thing in the same order on this side of the equation because, like I said, conservation of mass says I should have equal numbers of atoms and the same elements on each side of the equation. So if I count the number of atoms of potassium that I currently have, I have one potassium, I have one bromine, and I know that because there's no subscripts. If there's no subscript, it means there's one of those things. And I've got this subscript right here, which pertains only to the chlorine, and I have two chlorines. Now, just know, you guys, have a good eraser while you're balancing equations. That's my advice. Over here, I have potassium, and I have one potassium. I've got bromine right here. I've got two bromines, because that's what that subscript tells me. And I have one chlorine. So we just did part one. We set up each side with the correct elements and quantities, and now we have to do step two, which is to check for balance. I've got one potassium on each side. I've got one bromine on the reactant side, and I have two bromines on the product side. I have two chlorines on the reactant side, and I have one on the product side, so I'm not balanced. Now, when it comes to balancing, you guys, what I need you to remember is that we can't mess with the subscripts. Leave those subscripts alone. The only thing we can do is add coefficients out front, okay? Now, in terms of which one of these do I try to balance first, for this one, it doesn't really matter. I like anything that has a ratio of 2 to 1. Or 3 to 1, or 4 to 1, or anything to 1. Those are the easiest to balance, okay? So I'm just going to come right down the line, and I'm going to go right over here to bromine. Now, I've got two bromines here. I've got one here. I always put my coefficient on the side of the equation with the lower quantity. So right now, I only have one bromine. So I'm going to go ahead, and the only way that I can make this balance with the two that I have over here is to put a coefficient of 2 out in front of this compound of potassium bromide. Now that I've done that, you guys, I'm going to add any necessary coefficients. I did that, and I'm going to update my quantities. So I'm going to go ahead and update my quantities. Now I have two potassiums, because remember, the coefficient relates to anything in the compound. So now I have two potassiums, but I also have two bromines, and so I have to update that. So I've just updated. Now let's check for balance. Okay. Now, my potassiums are not balanced. My bromines are balanced. And my chlorines are still not balanced. So let's go ahead and balance my potassiums. I've got two potassiums here. I've only got one here, which means I'm going to put my coefficient on this side because this potassium is the lower quantity. So I'm going to go ahead and put my coefficient right there. And now remember, the next step, once we add our coefficients, we update our quantities. Let's do that. So this 2 pertains to not only this potassium, but also this chlorine. So now I have 2 potassiums here, I have 2 chlorines here, and my next step is to check for balance. So I've got 2 potassiums, I have 2 bromines, I have 2 chlorines. This equation is balanced. Hooray! 1 in the books. So let's go to number 2. I've got magnesium chloride getting together with potassium and forming potassium chloride and magnesium. So let's go ahead and do step 1. And if you remember, step 1 is to set up each side with the correct elements and quantities. Let's do that. I've got magnesium, I've got chlorine, I've got potassium. I'm going to do the same thing on this side of the equation in the exact same order. Magnesium, chlorine, and potassium. And the reason I do that is because that way I can just check them side by side for balance. Now I have to check their quantities. I've got 1 magnesium. Now this subscript, you guys, because there's no parentheses nearby, this only tells me the quantity of chlorine. So I have 2 chlorines and I have 1 potassium sitting right out here. I've got 1 magnesium, I've got 1 chlorine, and I've got 1 potassium. So let's check for balance. My magnesiums are balanced. My chlorines are not balanced. I've got 2 on the product side, 2 on the reactant side, 1 on the product side, and my potassiums are also balanced. So I only have one thing to balance, and that's going to be my chlorine to this point. This is a 2 to 1. This is the lower quantity over here, so this means this is where I'm going to put my coefficient on the product side, and I'm going to put it right here. Now that I've put my coefficient, I have to update my quantities. So I now have 2 potassiums, and I have 2 chlorines. Let's check for balance, because that's always next after we update. My magnesiums are still balanced. My chlorines are balanced, and my potassiums are not balanced. So that means I have to come back over to the reactant side because my lower quantity is here. I'm going to go ahead and put a 2 right in front. I'm going to update my quantities. And let's check for balance. My magnesiums are balanced. My chlorines are balanced. My potassiums are balanced. I'm all done here. I'm just going to clean that up a little bit so I can easily see what my coefficients say. And that's going to take us to number 3. Number 3 is a little trickier. We'll get there. So the first thing, again, if we go to this list, to set up each side with the correct elements and quantities: carbon, hydrogen, oxygen. Let's do the same thing in the same order on the product side: carbon, hydrogen, oxygen. So I have this little subscript that pertains only to the carbon, so that's going to be 3 carbons. This subscript right here only pertains to the hydrogen, so I have 8 hydrogen. This subscript right here only pertains to the oxygen, so I have 2 oxygen. Let's go to the other side. I've got 1 carbon right here, because again, this subscript, because there's no parentheses, only means that that affects the oxygen. So I've got 1 carbon. Hydrogen, I've got 2, because that little subscript is only for the hydrogen. Now notice, you guys, I've got oxygen in both of these compounds. So in this compound, and I'm going to write it above, I've got 2 oxygens here, and I've got 1 oxygen here. Now you notice, you guys, I didn't write oxygen twice, I just wrote it once, and all I have to do is add these 2 quantities together. So I've got 2 oxygens in the carbon dioxide, plus the 1 oxygen in the water means I have a total of 3 oxygens. So let's check for balance. Now that we have finished updating our quantities, let's check for balance. So my carbons are not balanced, my hydrogens are not balanced. Oh geez, nothing's balanced. So then you might ask yourself, well, which one of these should I start with? Should I try to balance the carbons, the hydrogens, or the oxygens first? I'm going to balance the carbons first. And the reason I'm going to balance the carbons first is it's 3 to 1. That's the easiest thing. Anytime we have something to 1, it's always the easiest one to balance. So I'm going to go ahead and do that. So I'm going to take this. Now, the coefficient's going to go here on the product side because this is the lower quantity. I have 1 here compared to 3 here. So I'm going to go ahead and put a 3 right out front here. And now that I've done that, I have to update my quantities. Now, because this is a coefficient, it relates to everything that is in that compound. So now I've got 3 carbons, and I've got 3 times 2, because whenever we take something with a subscript, we have to multiply it. So 3 times 2 is 6 oxygens. But remember, ladies and gentlemen, I still have that oxygen hanging out by itself over here. So I have to add these 6 oxygens plus this 1 oxygen for a total of 7 oxygens. Okay? So now that we've added our quantities, let's check for balance. So my carbons are balanced, but my hydrogens and my oxygens are not. So when it comes to picking which one of these to do next, so what I'm essentially doing is I'm trying to find sort of some common ground between when it's time to balance. All I know is that I've got more common ground with hydrogens than I do with oxygens, because 8 is divisible by 2, so that's going to make my life easier. If I want to balance this, I'm just going to put a 4 out in front of my hydrogen here, and I'm going to update my quantities again. Once I put a coefficient, the next thing is to always update your quantity. So now I have 4 times these 2 hydrogens here for a total of 8 hydrogens. This 4 means I'm going to have 4 oxygens over here now to go along with the 6 oxygens I have on the other part of this product side for a total of 10 hydrogens. So let's go ahead and check for balance now. We've updated all of our quantities, so if I look, I can see that carbon is balanced, hydrogen is balanced, but my oxygens are not balanced. Now I have the lower quantity over here, which means I'm going to go ahead and work on this side of the equation. And what I'm going to do is I have, the common number for 2 and 10 is going to be 5. And now if I update my quantities, I have 10 oxygens right here. If I check for balance, my carbons are balanced, my hydrogens are balanced, and now my oxygens are balanced as well. So there's a lot of back and forth with this, but just remember, it's a process. For those of you that can look at an equation and just do it in your head, you're lucky. I was just never that way, so this is the process that I've always done, and this is a good process to use, especially when we get into some of the more convoluted stuff. All right, let's do number 4. Again, you guys, our first step is to figure out what we have and how much of what we have. So I have sodium, I have sulfur, I have hydrogen, and I have chlorine. So on this side of the equation, I'm going to do the same thing in the same order. Sodium, sulfur, hydrogen, chlorine. Now let's figure out how much we have of each thing. So I've got 2 sodiums, I have 1 sulfur, I have 1 hydrogen, and I have 1 chlorine. On this side, I have 1 sodium, I have 1 sulfur, I have 2 hydrogens right here because that subscript tells me so, and I have 1 chlorine right there. So we've set everything up. We have completed step 1. We set up each side with the correct elements and quantities, and now it's time to check for balance. My sodiums are not balanced, my sulfurs are, my hydrogens are not, my chlorines are. I'm going to go ahead and just start with the top one here because I have 2 2-1 quantities, both sodium and hydrogen. I'm just going to start by using this side of the equation. I'm going to put a 2 right there, and now that I've put my coefficient, I have to update my quantities. This 2 pertains to the sodium and the chlorine, so now I have 2 sodiums and I have 2 chlorines, and now we have to check for balance. The good news is both of my sodiums are balanced, my sulfur is still balanced, but my hydrogen and my chlorines are not balanced. So it doesn't really matter with this one because it's all going to end up in the same place, so to speak. Both hydrogen and chlorine are 2 to 1s. You could use either one of these. All you need to know is that you're going to have to put a 2 out in front of the HCl, and we're going to have to update our quantities. So this 2 pertains to the hydrogen, so now I have 2 hydrogens here. This 2 also relates to the chlorine, so I'm going to have 2 chlorines there. So I've updated my quantities, and now it's time to check for balance. I have 2 sodiums, I have 1 sulfur each, I have 2 hydrogens each, and I have 2 chlorines, and I'm done balancing this equation. Let's go to page 2. Page 2. Actually, you know what? I need to get a different page 2. Hold that thought. I'll be right back. I thought I had done... Oh, there it is over here. All right, so page 2. I didn't want to spoil the fun surprise that is number 8. Sheesh. Okay, now number 5 is a busy problem, but I don't want you to panic over it. Okay, it's not as bad as you think. It's not easy, but it's not that terrible either. You see a problem like this and you automatically start to panic. And remember, you guys, that is why we have a process. Process fights panic. So let's start, you guys, by simply doing the work of number 1. We're going to set up each side with correct elements and quantities. So if I'm looking at this, I see that I have aluminum, I have sulfur, I have oxygen, I have calcium, I have oxygen again. Now, I don't need to write oxygen again. I've already written it, and even though it pops up again on the reactant side, I don't have to worry about it. And over here, I have hydrogen. So I have aluminum, sulfur, oxygen, calcium, and hydrogen. I'm going to put the same thing in the same order over here. Aluminum, sulfur, oxygen, calcium, and hydrogen. So let's figure out how much of these atoms I have on the reactant side. Well, I have a subscript next to my aluminum. That subscript is 2. This subscript is just hanging out with the aluminum here, so we have 2 aluminums. Now, what we have here is we have a polyatomic. We have sulfate. So you need to remember this little guy out here, okay? Because these parentheses, what that means is that everything inside these parentheses is related to this subscript. So I have to multiply that. So I have 3 times 1 sulfur is 3. Now I've got 4 oxygens in the parentheses, which means I have to multiply those 4 oxygens times 3, which gives me 12 oxygens. Over here, I have calcium. I have no subscripts, which means I have 1 calcium. I have another polyatomic. I have hydroxide right here, which means that I've got 2 hydrogens and 2 oxygens. Okay, so I'm going to go ahead. Let's deal with the oxygen first. Now, if you recall, I had oxygen over here. I had 12 oxygens here. I have 2 oxygens here, which means that I have to add those together. So on the reactant side, I actually have 14 oxygens. Okay, and as far as my hydrogens, I've got 2 hydrogens. That's what I'm going to put right there. So that's one of the most important things about a problem like number 5 is that I have to make sure that I'm getting these quantities correct. So, and sometimes it's easy for us to forget that we might have oxygen in one of these chemical formulas, and if I have it in another, I have to make sure it ends up in my total. Okay? Now, the reason I don't write oxygen down here at the bottom again is that it gets super confusing. You want to keep everything as tight as you possibly can. All right, let's go to our product side and let's see what we have for quantities. So I have aluminum with no subscript, which means I have 1. I have a hydroxide over here with a subscript of 3, which means I've got 3 oxygens and 3 hydrogens. Over here, I've got 1 calcium. I have an S. I have sulfate here, which means I have an S inside this parentheses with no subscript, so I have 1. And I have 4 oxygens right here. Now remember, I had 3 oxygens here. I've got 4 oxygens over here, so this quantity of oxygens on the product side is actually going to be 7 because I took 3 plus 4, which equals 7. So let's check for balance. In checking for balance, I can see that not much is balancing. So my aluminums don't balance, my sulfurs don't balance, my oxygens do not balance. Oh, look, my calciums balance. Hooray! And my hydrogens don't balance. So again, you guys, as far as determining where should you start when it comes to your balancing, I like to start with anything that has a ratio to 1. And I've got a couple of those. I have the aluminum with a 2 to 1 and the sulfur with a 3 to 1. It's up to you which one you start with. Like I said, I personally like to start with the simplest one. And in this case, that simplest one is going to be the 2 to 1. So I'm going to put my 2 over here, and the reason I'm doing that is because the aluminum on the product side is the lesser quantity, so I'm going to go ahead and put my coefficient there, and then I'm going to update my atoms. So I know that I can update aluminum. Now I have 2 aluminums. Now remember, you guys, I had 3 of each of both oxygen here and hydrogen, because this 3 relates to both of these things, but then I also have to multiply it by 2. So if I take 3 times 2, I now have 6 oxygens. But remember, I still had these 4 oxygens over here, so now I have to change my oxygen total to 10. Okay? The other thing I have to deal with is my hydrogen. I had 3 multiplied by 2, which means I now have 6 hydrogens. Okay? So now we've updated our totals. Now it's time to check for balance again. So I've got 2 aluminums. My aluminums are balanced. My sulfurs are still not balanced. I'm getting closer, but my oxygens are still not balanced. My calcium is, and my hydrogens are not. So now the simplest one for us to go ahead and balance is going to be our sulfurs, because again, that's a 3 to 1. So I'm going to go ahead and take that 3 and put it right here, because this is the lesser quantity. That's where the coefficient's going to go. So now I have to update my quantities. So this 3 means that I now have 3 calcium, so I have to write that down. I had 1 sulfur, but now with this coefficient, it means I now have 3 sulfurs. And I have to take this 3 times the subscript of 4 for the oxygen, which means I have 12 oxygens over here. But remember, I have 6 oxygens over here, and 12 plus 6 is 18. Now, you might be thinking to yourself, these numbers are getting crazy. Don't worry about the numbers. Once you finish updating your quantities, all you got to do is check for balance. Now, my aluminums are balanced. Now, my sulfurs are balanced. Now, my oxygens are not balanced, my calciums are not balanced, and my hydrogens are not balanced. But again, you guys, we go back to the idea that we choose the simplest thing to balance. Well, the oxygens are not going to be easy to balance, but the calciums are a 3 to 1. That looks pretty easy, and the hydrogen looks pretty easy too. Let's take the 3 to 1 because that's what we like to do. So we're going to go ahead. This time we're going to come back to the reactant side for our coefficient, because this calcium is the lesser quantity compared to this one. So we're going to go ahead and put a 3 here, and that's going to allow us to balance our calcium. So let's update that. We have to update what's in here. So we had 2. We had 2 oxygens, but we have to multiply it by 3. That gives us 6 oxygens right here. Okay. And then over here, don't forget these oxygens, we had 12. What's 12 plus 6? 12 plus 6 is 18. Okay. We have to work on updating our hydrogens. We had 2 hydrogens, but we have to multiply it times 3. That gives us 6 hydrogens. And we're done updating, and now we can check for balance. So I've got 2 aluminums, I've got 3 sulfurs, I've got 18 oxygens, I have 3 calciums, and I have 6. So we're balanced, and we're done. Phew, that one feels like a lot of work, but really, you guys, one of the things you want to remember is just keep going back and forth until eventually it works itself out, because it will. Okay, let's do the next one. So I have sodium hydroxide and sodium oxide and water. Okay, so let's go ahead and set up both sides of our equation. So I've got sodium, I've got oxygen, I've got hydrogen. On this side of the equation, in the same order, I have sodium, I have oxygen, I have hydrogen, and let's take care of getting our quantities next. So this type of reaction, you guys, just a quick reminder, this is a decomposition reaction. So as far as the types of reactions that you have, this is decomposition because I have a single substance, sodium hydroxide, that is breaking down or decomposing to form sodium oxide and water. So when you have one substance that breaks down to form two or more substances, that's a decomposition reaction. Learning! All right, so I have one sodium, I have one oxygen, and I have one hydrogen. Over here on this side, this subscript only pertains to the sodium, so I have two sodiums. I have one oxygen here, but look, I've got another oxygen over here for a total of two oxygens. And this subscript pertains to the hydrogen, so I have two hydrogens. So now we have to go ahead and sodiums, check for balance. Sodiums are not balanced. Oxygens are not balanced. Hydrogens are not balanced. But look, you guys, they're all 2 to 1s. So your solution is simple. Put a 2 out there. We're putting the 2 on the reactant side because these are all the lesser quantities compared to what's on this side. So the coefficient always goes on the side where you have the lesser quantity. And now it's time for us to update. This 2 relates to everything in this chemical formula, which means I have 2 sodiums, I have 2 oxygens, and I have 2 hydrogens. Now we have to, now that we have finished updating, check for balance. 2, 2, 2. That was an easy one. Nice. Okay, let's jump down here to number 7. Number 7, again, is a little bit busy, but not too bad. All right, so let's go here. We have silver, which is Ag. We have nitrogen. We have oxygen. And over here, we have copper, Cu. We're going to go over here on the other side of the arrow to the right side, where we also have silver, nitrogen, oxygen, and copper. And let's figure out our quantities, because that's all part of, that's right, step 1, where we figure out, we set up each side with the correct elements and quantities. There's no subscript on the silver, so we have 1 silver. Now, there's no parentheses here, so this subscript of 3 only relates to the oxygen, which means nitrogen's all by itself. We have 1 nitrogen. We have 3 oxygen, because that subscript is telling us how many oxygens, and we have 1 copper. On this side, we have 1 silver. Now we have, this is now a polyatomic ion, NO3, and this subscript specifically relates to both things that are in the parentheses. There's no parentheses here, so we only have 1 copper. So we have 1 nitrogen inside the parentheses. If we take that 1 nitrogen times 2, that means we have 2 nitrogen. We have 3 oxygen inside the parentheses times 2. 3 times 2 is 6 oxygen. So we have finished updating this side. Let's check for balance. Our silvers are balanced. Nitrogen, no. Oxygen, no. Copper, yes. In terms of choosing which one to balance, I'm going to try and balance my nitrogen because that's a 2 to 1. This is the lower side right here. This is the lesser quantity. So I'm going to put my 2 out in front of this compound, and now it's time to update my quantities. And again, remember, you guys, coefficients relate to everything that is in this formula. So now I have 2 silvers, I have 2 nitrogens, and I had 3 atoms of oxygen here, but I have to multiply 3 times 2, which means I now have 6 oxygen, and I still have my 1 carbon over here. Now that I've done my updating, let's check for balance. Well, my silver is no longer balanced, but my nitrogen is balanced, my oxygen is balanced, and my copper is balanced. So I notice that it's the product side that has the lesser quantity. So I'm going to take 2, coefficient of 2, and put it out in front of silver. And now I'm going to update my quantities. So I'm going to go ahead and write down that I have 2 silvers, and now let's check for balance. I have 2 silvers, I have 2 nitrogen, I have 6 oxygen, and I have 1 copper. So again, you guys, my process is always the same. Okay? Set up each side, check for balance. Add any necessary coefficient that I see, and then update quantities and check for balance. These 2 things, you guys, are probably the most important step, because anytime I add a coefficient, the next thing I have to do is update quantities. Then I check for balance. These 2 things are huge, because sometimes what happens is students want to skip the updating of the quantities. They simply want to just jump to the end. Take the time to go through the process. Now let's go ahead and work on number 8. Number 8 is kind of a nasty little problem. And this is one of those that I simply call them trial and error problems, where sometimes when I was doing this problem, I could not find a clear path to do it in my head. So I simply trialed and errored until I got what I wanted. Now, with that said, the process starts the same. We set up each side with the correct elements and quantities. So carbon, hydrogen, and oxygen. Then we do the same thing on the other side in the same order. Carbon, hydrogen, and oxygen. Now let's do our quantities. Over here I have 6 carbons. This subscript means 14 hydrogens, and this subscript right here means 2 oxygens. On the other side, I have 1 carbon, I have 2 oxygens here, and I have 1 oxygen there for a total of 3 oxygen. And this subscript tells me that I have 2 hydrogen. So I've updated my quantities. Let's check for balance. Nope. No. And no. All right. Now there's a lot going on here. So I'm simply going to start with the easiest one for me, which is, if I notice I've got a 6-to-1 ratio, I like to 1 ratios. I'm going to go ahead and start with that. So I'm going to go ahead and put a 6 out in front here. That way, when I update my quantities, that's going to give me 6 carbons, and that's going to give me 12 oxygens here, plus the 1 oxygen I have over here, for a total of 13 oxygens. Let's check for balance. Yay for me, I've balanced my carbons. However, my hydrogens are still out of balance, and my oxygens are still out of balance. Well, let's see what I have here. I think it's easier to balance these 2 than my oxygens, because 14 is divisible by 2, and specifically, if I put a 7 out here, that means that's going to allow me. So I'm going to update my quantities here. So now I have 14 hydrogen. So I've managed to balance because I have 7 times 2, which is 14. But remember, I still have to update my quantity of oxygen. So I've got 7 oxygens right here. So 7 times 1 is 7. And if you recall, I have 12 oxygens here, which gives me a total of 19. Oof. That's a little bit nasty. Okay, so let's talk about how to deal with this. So now what we're doing is we are getting into the territory, for me at least, where it gets a little harder to figure out what to do. I've got my carbons balanced, I've got this balanced, but I don't have this balanced. And what I have to ask myself is this: is there a number that 2 and 19 have in common? And the only one that comes to mind right away is the number 38. And the only reason I say that is 38 divided by 2 equals 19. Okay? And there's no fractions in balancing equations. I can't take a half of something or a 0.5. Okay? So this is what we're going to do. And this is where things get, and like I said, I just trialed and errored this until I felt I was onto something. So what I'm going to do is I'm going to go ahead and put 19 right here, okay? And what I have is 19 times 2 is 38. So I'm going to update my quantity and check for balance. Well, obviously, this isn't balanced, okay? Yes, I have my carbons balanced. Yes, I have my hydrogens balanced, but I don't have this balanced. Now, anything I do, you guys, I'm going to have to end up doing on the product side because right now, this oxygen is the lesser quantity. So, right off the bat, what I want to say to myself is I don't want to lose the balance I've created over here. And in order to keep my balance over here and over here, is I'm going to mess, it will be, this is going to sound weird, it's easier to mess with this side than it is with this because of this big old molecule right here, okay? The fact that I have this molecule with these big subscripts, it makes it harder to deal with on this side of the equation, okay? At least I think it does, but it's just something to consider, okay? So all we know is that we have to definitely increase this particular quantity. So there's a couple of different ways you can do it. And all you need to know to start with is I'm going to go ahead and just say, all right, I know that whatever I do, I'm probably going to have to double my quantities. So I'm just going to mess around with it for a minute. And I'm going to start by simply doubling this. I'm going to go 12 here, I'm going to go 14 here, and the reason I'm doing that is because I know that when it comes time to balance, I can easily do it by manipulating this eventually. So let's see what happens if I do this. Okay, now, I just put 14, so I know that I'm just going to go ahead and erase these because I know I'm going to update everything. So if I do this, 14 times 2 is 28 hydrogens. I've got 14 oxygens over here. Over here now, I have 12 carbons, and I have 24 oxygens. And if I add those up, that works out for me because now, look, 24 plus 14 is 38. So I just managed to balance my oxygens. Hooray for me. Because I know I had to gain a lot of oxygens. That's why I just went ahead and doubled it. Now, if I hadn't balanced this, I would have just kept messing with this until I got this 38 balanced. So now what we can do is we can go back here. We can go back to this side of the equation because if we look, my carbons and my hydrogens are no longer balanced. But all I have to do is put a 2 out in front of here and update. So now I have a 12 here. I have 28 here. And now my formula is balanced. And like I said, this is one of those that you just kind of, and this is the reason I went ahead and made this big jump to doubling both, is that experience tells me that's what I'm supposed to do. That you make that big jump because you know you have to gain a huge quantity of oxygen when you're trying to balance from 19 to 38. So it just means we need significantly more molecules, and it still gives me the opportunity to use a nice even coefficient over here if I need to. So the good news is you won't see very many of these like this in your balancing because it's kind of wicked. It's a wicked thing to do to students, but know that you can still just go through your process until you get to the end. Okay? All right, so that's it. That's your first practice. Just know there are more practices coming, and after a while, this process becomes very intuitive. But I can't stress this enough, you guys, how important, if you're not one of those people that can just look at a problem and balance it, this process is super helpful and will become very meaningful to you. Okay.